So hi guys, welcome back to part 3 of soil compaction. Okay, so determination of field unit weight of compaction. When the compaction work is progressing in the field, knowing whether the specified unit weight has been achieved is useful. The standard procedures for determining the field unit weight of compaction include: number 1, sand cone method; number 2, you have rubber balloon method; and number 3, you have nuclear method. So sand cone method, ASTM designation D1556. So here in the sand cone method, you have a plastic jar or a glass jar and may naka-attach na metal on top. Then, it is being filled with uniform dry Ottawa sand. Okay, so i-determine natin yung combined weight ng jar with the without the Ottawa sand, the combined weight of the jar with the Ottawa sand. Okay, kasi yung mawawalang weight sa loob ng Ottawa sand, yun yung gagamitin natin to determine our volume. Okay? So yung weight yung weight ng Ottawa sand na kompleto minus the weight of the sand na weight of the sand to fulfill the cone only. Okay? Then, ma-determine na natin yung ating volume. Okay? So, the dry unit weight is equivalent to the dry weight of the soil excavated, okay, which makukuha naman natin divided by the volume. So if this is your apparatus, nasa loob niyan is the Ottawa sand, then yung mag-fill na Ottawa sand dito, ito yung gagamitin natin to determine the volume of the excavated soil. Okay? Mamaya makikita natin yan sa example. Next would be the rubber balloon method, ASTM designation D2167. The procedure of the rubber balloon method is similar to that for the sand cone method. A test hole is made in the moist weight of soil removed from the hole, and its moisture content are determined. However, the volume of the hole is determined by introducing into a rubber balloon filled with water from the calibrated vessel, from which the volume can be read directly. Then, nuclear method. Nuclear density meters are often used for determining compacted dry unit weight of soil. The density meters operate either in drilled holes or from the ground surface. It uses a radioactive isotope. The isotope gives off gamma rays that radiate back to the meter's detector. Dense soil absorbs more radiation than loose. The instrument measures the weight of soil per unit volume and the weight of the water present in a unit volume. So in short, gagamit tayo ng nuclear density meter and a calibrated vessel with rubber balloon. Ito naman yung sa isa. Okay, so we will be using apparatuses, this type of apparatus. Okay, so an example of this one. An example of the sand cone method. So you have here the mass laboratory compaction test results for a clayey silt are given in the following table. So the moisture content 6, 8, 9, 11, 12, 14. So these are controlled samples. And the dry unit weight are given as follows. Okay? So determine the unit weight of compaction in the field. Then relative compaction in the field. So the calibrated density of Ottawa sand is 1,570 kg per cubic meter. This is constant. Calibrated mass of Ottawa to fill the cone is 0.545. The mass of the jar plus cone plus sand bago gamitin is 7.59. So katulad ng sabi natin kanina, kukunin natin yung mass nila, yung jar, yung puno, and pati yung funnel, okay, or yung cone. Then, the mass of the jar, the cone, plus the sand after use. So, ang gagawin natin to get, before that, the mass of the moist soil from the hole is 3.07 kilograms. The moisture content na makukuha natin through laboratory dry ovening, we have 10.2%. Okay? Okay. So, para makuha natin yung mass of sand used to fill the hole, isusubtract natin yung ito, 7.59 bago gamitin and after gamitin. 7.59 minus 4.78. 7.59 minus 4.78. Therefore, the mass of the sand used to fill the hole and the cone is 2.81. Take note, etong cone natin, magkakaroon pa rin yan ng sand. So, ibabawas natin yung sand, weight ng sand na nasa cone, which is 0.545. Therefore, the mass na nasa hole lang is 2.265 kilograms. Okay? So, to determine the volume of the hole, we have 2.265 kilogram divided by the dry density of the Ottawa sand. What is the dry density of the Ottawa sand? 1,500.70. So 2.265 kilograms divided by 1.570 kilogram per cubic meter. Kilogram will cancel out. Cubic meter, pupunta siya sa numerator. Therefore, this is the volume. Okay? So for the mass density of the compacted soil, it is equivalent to the mass of moist soil divided by the volume of the whole as whole. So ano ba yung mass? It is 3.007 kilogram. So 3.007 kilogram divided by the volume. Then this is our moist density. So the moist unit weight, just simply multiply the density by the unit weight of water, which is 9.81 divided by 1,000 to make it kilonewton per cubic meter. Now for the dry unit weight, just simply divide the moist unit weight by 1 plus the moisture content. So 1 plus 10 divided by 100, that is the dry unit weight. Okay? Saan nakuha yung 10? Yan yung moisture content. So 10%. Naka-percent siya, kaya siya dinivide ng 100. Okay? The result of the laboratory, ano yung unang question natin? The dry unit weight. So, nasolve na natin yung dry unit weight. Next, ang isa-solve natin is the relative compaction in the field. So, the result of the laboratory compaction test are plotted in figure 6.27. So, ito yon. So, paano natin makukuha yung relative density? Relative compaction rather. Yung relative compaction natin sa field. Okay? So, we have here 18.56 yung dry density natin divided by the maximum. So, paano natin makukuha yan? Iga-graph natin yung unang given na dry unit weight. 14, from the previous video, we were able to graph. Okay? So, moisture content versus the dry unit weight. So, 6, 14.8. 6%, 14.8, dito sila magmi-meet. Next, 8, 17.45. 8%, 17.45, dito sila magmi-meet. Next, 9%, 18.52. 9% around here, 18.52 around here. Ayan, dyan sila magmi-meet. Then, 11, 18.9. 11, then 18.9 around here. Next, 12, 18.5. 12, tapos 18.5. Yan, dyan sila magmi-meet. Then, 14, 16.9. We have here 14. Then, you have, no, this. 14, 11, 12, 13, 14. 14, you have 16.9. Dito sila mag-meet. Then, connect it by a smooth curve. Yung pinakamataas or the peak of the graph, hanapin nyo yung point na yon, project it horizontal, then that is your maximum dry unit weight. So for the relative number, that is not relative number, a relative compaction rather. For the relative compaction R, the dry unit weight in the field, which is 18.56, divided by the maximum dry unit weight from the graph, which is 19. Therefore, your relative compaction is 97.7%, which is quite high, and that is very, very good. Okay. Next. So for a given soil, the following are the results of compaction test conducted in the laboratory. So ganun ulit. Okay. So you have there 12, 14, 16, 18, 20, 22, 16.34, 16.93, 17.24, 17.2, 16.75, 16.23. After the compaction of the soil in the field, sand cone test, control test were conducted at 5 separate locations. So ito yan. Magkakaibang location. The dry density must be at least 95% of the maximum dry density. Moisture content show to be within plus or minus 2% of the optimum moisture content. Okay, so what do we know? What do we need to do? Is to determine the zero air void unit weight. So, gagamitin natin is magsasaturated tayo. So, we will be using this formula. So, the saturated zero air void is equivalent to the unit weight of water divided by W plus 1 over the specific gravity. So, using this equation and this value, tapos saturated natin is 100%. Ito yung mga lalabas na values. Okay? So, from the plot, if we are to plot that, 12, 20.12. So, 12, we have 20.12. Okay? Next, we have 14, 19.33. 14, tapos 19.33, ito. Next, 16, 18.59. 16, then 18.59, ito. Tapos, we have ito. 18, 17.91. 18, 17.91. Tapos, 18, 20, 17.28. 20, 17.28. Then, 16, 22%, 16.70. 22%, 16.70. Then, connect it by a smooth curve. Okay? Connect it by a smooth curve. Now, ipa-plot naman natin yung una na yung dry density natin. dry unit weight rather. Ipa-plot natin yung ating dry unit weight. So 12, 16, 34. So 12, 16.34 ito. Okay? Next, we have 14, 16.93, 14, 16.93, 16, 17.24, 16, 17.24, 18, 17.2, 18, 17.2, next, 20, 16.75, 20, 16.75, and for the 22%, that is 22, 16.23. 16.23. Now, kung saan nakatapat yung natin, kung saan nakatapat yung highest point dito sa ating dry unit weight, itong dry unit weight, plinat natin siya, saan yung highest point, project it horizontally papunta sa ZAV. Okay, zero air void. And kung saan mag-intersect horizontally yon with our unit weight ZAV. Therefore, that is your maximum dry unit weight. Project it horizontally. That is 17.4 kilonewton per cubic meter. Okay? Next, for the optimum moisture content, ang sabi natin dito, it is plus or minus, ayun, plus or minus 2. Okay? So, for the plus and minus 2, what is 0.95% of your, what is 0.95%? Ito yon. This is our unit weight of 65%. No. 65%. Sorry. That is 95%. Yung highest point, balikan natin yung highest point. Yung highest point natin, which is 17.4 kilonewton per meter. The moisture content is 16.8%. So, yun yung ating magiging value, 16.8%. But, pasok ba siya sa ating condition na plus or minus 2? So, yes. So, the plus or minus 2 is ito, 14.8 and 18.8%. Yan yung ating plus or minus 2. Yan lang yung pwede natin gamitin na moisture content for our maximum dry unit weight. Okay? So, based on the specification, the dry unit weight must be at least 0.95%. So, 0.95 of 17.4 is 16.54 with a moisture content of 16.8 plus minus 2. So, ito yun. And the zone is shown here. Ito yung zone na yun. So, from this point to this point, ito lang yung ating moisture content. For control test, the following table can be prepared. Okay? So, using those values, then therefore, itong mga location natin, pwede natin makuha yung ating dry unit weight. Okay? So, take note ha, sa sa problem natin, meron tayong iba't ibang location, 1, 2, 3, 4, 5. And meron tayong mga densities. And we have different moisture content. Okay? So, we can solve our dry unit weight. So, we have here the density times 9.81 divided by 1,000. Tapos, tanggalin mo yung moisture content, makukuha mo yung dry. So, pasok ba? 17.5, 17.36, 16.51, 16.35, 18.41. So the results of the control test are plotted in figure 6.28. So nandito yun. So from the plot, it appears that the test at location 1 and 2 meet the specification. Pasok, ito, which is 17.4. Malapit. The test location 3 is a borderline case. So 16.51. So 16.54 at saka ayun, 16.44. So nasa borderline tayo. Okay? But there is some error for at least for the test location in 5 since it falls above the zero air void line. So may error tayo sa number 5. Ito yung 5. So this is 1, this is 2, this is 3, this is 4. So okay lang, malapit sila. Si 1 at saka si 1, 2, 3, and 4. Pero si 5, lagpas na siya. So that is our error there. Okay? So compaction of organic soil and waste material. Organic material in a soil reduces its strength. Soil with a high organic content are generally discarded as material. In certain economic circumstances, slightly organic soils are used for compaction. Organic soils are desirable in many circumstances: agriculture, desertification, mitigation, and urban planning. But for structural, we should try to avoid using organic material because organic material are decomposing. So pag nag-decompose yan, mag-iiba yung kanyang physical component. So there might be a possibility na magkaroon ng settlement kasi nag-i-increase yung void kasi nagde-decompose siya. Nag-iba yung kanyang physical property. Nadagdagan yung void, so pag nadagdagan yung void, pwedeng magkaroon ng unwanted settlement. So as much as possible, we try to avoid organic material for backfill for structural. Okay? Special compaction techniques. So we have a vibroflotation. So a technique in situ densification. When we say in situ, it is in place. Doon mismo sa location. In situ, in place. In location. Okay? The process involves vibrofloat unit, also called vibrating unit, which is about 2.1 meter long. Okay? So the jet at the bottom of the vibrofloat is turned on and lowered into the ground. The water jet increases, quickly condition the soil. It allows the vibrating unit to sink into the ground. Granular materials is poured on top of the hole with water from the lower jet and transferred to the jet on top of the vibrating unit. The water carries the granular material down the hole. The vibrating unit is gradually raised about 3.3 meter and held vibrating for about 30 seconds at each lift. This process compacts the soil to the desired unit weight. So ito yon. So this is your vibrofloat. So yan. Stage 1, papunta siya sa desired depth natin. Then from there, maglalabas siya ng tubig and at the same time, binubuhos yung ating filler. Habang binubuhos yung ating filler, we are naglalabas tayo ng tubig to densify. And nagva-vibrate din yan. Okay? So habang tumataas, na-compact na yung ating material sa ilalim. Okay? So yun yun. So yun. Pupunta yung jet sa bottom. Andito na siya. Pinasok na sa bottom. And habang papataas, the water jet increases quick condition. It allows the vibration to sink in the ground. Okay? So, yan, nagsisink pa. Then, pag nasa ground na siya, the granular material is poured from the top of the hole. The water from the jet is transferred to the jet on top of the vibrating unit. This water carries granular material down the hole. So, nilalagay na yung granular material sa ilalim hanggang papataas. Okay? So the grain size distribution of the backfill material is an important factor that controls the rate of densification. It was defined by Brown, and it was called the suitability number for rating backfill. So the suitability number is equivalent to 1.7 times the square root of 3 divided by D50, diameter 50, plus 1 over D20 squared plus 1 over D10 squared. D50, D20, and D10 are the percent materials diameter. Okay? Kung ilang percent yung materials na yun na retain sa diameter na yun. Okay? So, if the suitability number is within 0 to 10, it is excellent. 10 to 20, it is good. 20 to 30, it is fair. 30 to 50, it is poor. 50, unsuitable. Hindi natin siya pwedeng gamitin pang backfill. Take note ha, ang pinag-uusapan natin dito, backfill. Okay? So, for the dynamic compaction, ito yun. This is our dynamic compaction. We have a weight and it is being lifted at a certain height, then bibitawan. Pag binitawan yan, ito na siya. Nako-compact niya na yung ating soil. So, that is dynamic compaction. So, the significant depth of densification is equivalent more or less to 1/2 times the square root of W sub H times H. So W sub H is the dropping height and H is the height of drop. No, WH is the dropping weight rather, sorry. The weight and the H is the dropping height. So in English, it is 0.61 times the square root of W sub H times H. Okay? So ito yon. Ito yung ating WH and the height is our H. Okay? So for our last example, the following are the details for backfill materials used in a vibro flotation project. D10, 0.36 mm, D20, 0.52 mm, D50, 1.42 mm. So S sub n is equivalent to the sub 1.7 times the square root of 3 divided by this divided by D50 squared plus 1 over D20 squared plus 1 over D10 squared. What is our D10? Substitute 0.36 squared. D20 0.52 squared. D50 1.42 squared. And therefore, the answer is 6.1. Okay? So my suitability number is equivalent to 6.1. And going back to our table, it is an excellent material for backfill. Okay? So pag ginamit mo yung material na yon or yung type ng soil na yon pang backfill, okay siya. Okay siya pang backfill. So you will not be, more or less, you will not be experiencing any problems. Okay? So balikan lang natin tong graph na to. So you have here the summary evaluation of fill material for compaction based on SOWERS and Highway Research Board. So for gravelly, GW, rubber tired, steel wheel, vibratory. Good. Rubber tired, steel wheel, vibratory. Good. For GMGC, rubber tired, ship's foot, good to fair. Okay siya. For sandy, SW, SP, SM, SC, ito yung mga gagamitin nating heavy equipment. And ang result niya is good to fair. But for silty, ML and MH, rubber tired, ship's foot, it is good to poor and fair to poor. Okay? Okay pa naman yan. But for clayey, CL, rubber tired, ship's foot, medyo fair to poor na ang ating kinakalabasan na unit weight. Take note ha, unit weight ito. The higher the value, the better. Kasi mas compacted siya, mas mataas yung kanyang shear strength. The lower, the Hindi ganun kaganda kasi it is not well compacted and mababa yung kanyang shear strength or yung kanyang dry unit weight. So, mas mababa yung capacity na pwedeng i-carry ng ating soil. Okay? So, if there's any question, just comment down below sa post kung saan ko ipopost yung mga links ng video na ito sa group page natin. Okay?